So had I been able to get connected to the Wi-Fi, I was going to show off some links on GitHub. There's a lot of useful material out there. The 2 links that I have up there are really if you're going to try and get started with Pester, there's a lot of great examples that kind of walk you through different scenarios. The scenarios that it doesn't work through are what I'm hoping to walk through today and kind of pin that together of, they have this example out there, how do I actually build it into something that'll help me in my day-to-day job? So because we can't look at that, before I actually start getting into any code, I want to talk about why Pester exists, right? And it's really for 2 reasons. It's really all about test-driven development is one side of it, and the other side of it is infrastructure as code, right? We keep hearing that buzz term all over the industry of, hey, infrastructure should be just code. And in order to achieve that, you need a standard framework to test that infrastructure, right? Because once it's up and running, you expect things to be there. And as we all know, glitches happen, bad things happen, and you have to be able to find that as fast as possible, right? And so Pester gives us the ability to do both of those things, both the PowerShell that we've written and test the environment in which we're running it. So that's the real quick sales pitch as to why you should learn Pester. So with that, right, as all good PowerShell people do, we start with looking at what commands are in the module. And we quickly see that there's quite a bit. And we see a lot of these funny looking commands that don't follow the verb-noun standard of PowerShell. And that, in this case, is actually a really good thing. That makes it so we can write tests that are human readable, right? We can write a test that says, I'm describing this problem in the context of this, and I expect it should be this, right? That's a very human readable thing. That's fantastic. And as we look at these commands, we see we have describe, we have context, we have it, and if we scroll up a little bit, we see we have a should in here. We have a should. And that's great, right? That's great that we can write something that's human readable. But that's not the only selling point to Pester, right? Pester also has what's considered a mocking functionality, where I can simulate an environment all within my PowerShell, where I never have to actually reach out to the environment to change things or modify it. I can test it all within my laptop before I actually run it out in the wild. And that's fantastic for a lot of different reasons, and I hope I can show that to everybody. So we're going to start first with, well, how do we write a Pester test? And I'm going to start, for me, it's far more natural to start with the how do I test my code and move out to how do I test the environment. That's how I learned how to write Pester, so that's how I'm going to present it today. You can really start anywhere. Pester will run with it. So this first example is the new -fixture commandlet in that module, and it's got 2 parameters, right? I give it a path that I want to create my test, and then I give it a name. And when I run that, I can see that I have 2 new things. I have this empty file. It says I have a function called remove temp data, right? It's a very simple empty function. I then can take and look at this .test. And this is our first interaction with Pester. And it's important to note right out of the gate that the only distinction between these two is one has the word tests in it. And .test is a keyword in Pester. When I run Pester, it's going to recursively go through any directory that I give it and find anything that says .test in it, and it's going to run it. Whether it has Pester stuff in it or not, it's running. So if I have just a generic file that says, hey, remove all AD accounts, .test.ps1, guess what? It's going. It's going to happen.
Does that invoke the generate resume.test?
That, yes, it does. Absolutely. So that's kind of the first precautionary tale that I have to tell is just be cognizant of anything that's a .test, anything is going to get run by Pester. So as we dissect kind of what comes out of the box, we see these weird things at the top that seem a little a little unusual. At least they did to me at first. And it's a $sign here and a $sign soot. And to be very honest with you, I have no idea where the $sign soot came from. That is just a nomenclature that exists within Pester. I don't know, but you see it everywhere. And so really all these first two lines are meant to do is to say, I'm in a directory. Take and prune out that .tests from my file path, and then I want to take and pass those in to my operator, and I want to run whatever that file is. So I've now not only am running anything with a .test, but I'm now also going to run a file with the same name that doesn't have .tests. And we can see that all came out of new fixture, right? Our two files, this all matches so far. Again, that file has just an empty function in it. So then we move a little further and we see, oh, there's a describe, and we see an it, and then we see should be false. And because I'm running Visual Studio Code, I have this nice little run test button, and that will, in my terminal, run that test. And it gives me some really nice output out of here saying, hey, guess what? I was doing something useful. I expected false, but I got true. Hey, that's nice. Thanks for telling me the obvious, right? So if we take and we trade that around to be $sign true, and we rerun this, reruns, and we get a pass, right? We don't get any other output other than, hey, guess what? That test passed. We don't get what we were expecting. We don't get what it should have been, and none of that. Just says, hey, guess what? Everything that was in that it block passed. And that's awesome, right? We'll see where that becomes really cool moving on. Any questions so far? Great. So we'll move on to some other fun stuff. And we'll move into this simple unit testing. And so we have this function. Again, a really simple function. And I'm keeping the function simple on purpose because I want this to be focused on Pester and not what exactly is going on in a function, right? And we can do a lot of cool things with a lot of really simple functions. So all we have is this get temp data, and all it does is says, show me what's in my temp folder, right? Simple. That's about as simple as they get. In my test, I have all kinds of stuff. And here's where we start to see kind of the power of Pester. And so I've changed this a little bit. Instead of trying to run a PS1 file, I'm now running a PSM1 file. This is usually where I run Pesters in my modules, test my functions, so this is a more common practice for me. It does also allow me to run import -module, right? Otherwise, those first three lines are the exact same. There's nothing really special going on there. I'm just trying to remove tests out of it. So once I've imported that single file, I can now move into my testing. And so the first thing I do is I give it a relevant name that I'm describing get temp data. And my name is, I'm expecting this thing to return a directory object. So I run that actual function. And I give that data to this $sign result. I can then test that result as many times as I want, in many different ways as I want. Each one of those lines is called an assertion. And there's no limit to how many assertions I can put in an it block. The limit is the first one that fails ends the execution. So, right, if I have this first one and my $sign result is in fact empty, I will never find out that it was not the correct type. Which makes sense, right? If I didn't get anything, I can't figure out what type it is because it didn't exist. But if I did get something, I can then take and make sure that I got the right type back. And I can continue that as far as I want to go. I also see that I now have this -because. And that really helps out when you're trying to figure out what somebody else was doing, right? I can put in -because, and when it fails, that will print out with the rest of it and tell me, hey, I was expecting this, and I got this, and then here's some help messages, right? I was expecting that because we're testing things, and we should have gotten output. So if it comes back as empty, well, that's not good, right? This is a very simple example. A lot of cases where I work, we put in URLs to help documents. So you can click on the URL and go to the document and get a much fuller description of what's there. So let's run this. So if I just run invoke Pester in that directory, right? It runs anything in that file or anything in that directory with that data. And I get back a pass. And again, I don't get any of that other data. I don't get the because, I don't get the result, I don't get anything. It just tells me, guess what? That condition passed. And that, I promise, is a really good thing, right? Because when you're testing, you don't need all of the noise. You just need the failures. It's all you really care about anyway, right? What failed so I can go fix that problem.
Find out what else broke.
Exactly. So if I change this to be a should be null or empty, and I run it, now I get that failure. And now I get all of that extra data, right? Expected null or empty, because we're testing things, right? But got, and again, you see how this is more human readable, right? This is something I can hand off to other people, this output, and expect them to have some sort of an action, some idea of what's wrong and why, right? That's the selling point. So to clean up my test at the very end, I do a remove module so that if I'm running this as part of a build for my PowerShell modules, I know that if another test down the line needs this same function, it can import it in that space and I'm not overwriting anything. Questions? Comments? Make sense? All right. So let's move to something a little more complex. And I called this less simple unit testing because I felt like calling it complex testing was going to be misleading. Just being honest. So now we've got a function and it's got a little more to it, right? I mean, I'm actually doing some parameter validation. Hey, does that path exist? If not, we should throw an error, right? If it does exist, give me back my directory. Again, very simple stuff, right? This is probably PowerShell 101 in this function. But if I go to my unit tests, holy moly, that's a lot of stuff, right? And we see again at the top, it's all the same. That's all copy and paste, those first 3 lines, right? Every single Pester test that you write for testing your code should start with those 3 lines in one flavor or another. If it doesn't, you're probably doing something wrong. So after that, I move into my describe. And I'm describing the function that I'm testing. And then I say, I'm now going to take and test that it returns a directory object. I run the function, right? This all looks familiar from last time. But so now I'm going to take it a step further. And I want to say, hey, guess what? I know we have these standards of my function name that have a dash in it. Right? You guys ever get that from one of your coworkers where they just have this long string of stuff that they've cased funny and that somehow makes sense to them, right? So I want to make sure that anything I've got has that dash in it. And so I can test that by getting content. I pipe that to select string. And then I use the match operator to run some regex and tell me that that function part of my file has a dash in it. So if you know regex, this is really cool, right? Regex enables all kinds of really interesting things in PowerShell. If you don't know regex, 10 out of 10 recommend. After that, I move into, so I know now that I have a dash there. But now I want to make sure that it actually matches, and that's backwards, the verb dash noun standard. Right? So I want to take it a step further and make sure that I've actually started following other things in that best practice. And so again, I can do a get content. I set the value of that content to a variable. And now I can do some really funny stuff with regex and using the replace operator in strings. And now I collect in all of my verbs from the PowerShell system. right? And then I can take those two results and compare them, all within that it block. And if any of that fails, anywhere in there, right? Like say I'm on a system and get-verb doesn't work. Pester will tell me that. Out of the box. I have to do nothing special. So at the end of it, right, so I have $verbs, which is an array of names that are registered in PowerShell as valid verbs. I then have a string, that's my $verb, and I just want to make sure that one exists in the other. And that's what should-contain gives me. It's able to do that lookup in the array and tell me does it match. And then lastly, I take it a step farther and go, hey, guess what? I know that I have an error condition and that I'm expecting that if I give it a bad path, that it throws an error, right? That's something that I want to make sure works because that is probably important for somebody else down the road. So I take and I make a script block and I run my get temp data with a bad path. And I can pipe that to should throw. And that will catch the error for me and tell me whether or not that actually threw an error with no errors on the screen. I promise. It's going to be great. Everybody ready? So, if I run Pester, again, I'm just giving it the directory. And I have all passes, whole way across the board. Right? And I even get the output. Hey, guess what? That function threw an error on a bad path. Fantastic. I know my parameter validation is working as I would expect it to. Good so far? Yeah? All right. To wrap this up, right, as always, we take and we remove that module. So now let's get into context and mocking. So now we've got a destructive command, right? We're going to remove temp data. Oh my God, we're deleting stuff. This could be catastrophic in every possible way, right? But it's still a very simple function. We're going to find everything that's in our temp directory, and we're going to delete it. As we move into that function, we again see our top three lines, same as always, right? Then we get into our describe, and we're describing remove temp data. And now I have this context. Anybody want to take a guess as to what the difference is between context and describe? Nothing. Not even a little bit. There's no difference. Is that surprising? A little? Yeah? Yeah, it's context is used for a scoping mechanism only. So as you start mocking different objects, context allows you to take and just create a individual scope to mock things. So that if you're going to take and say mock remove dash item, you can do that within just that test. And then you can move on in your describe to the next thing and the next thing, and know that whatever you've mocked in that other context doesn't matter down below. That's what it's there for. To that point, there's no limit on how many describes you can have in a file. So if I want to have a 400-line Pester test that tests every function, and I'm going to have a describe for each one of them, no problem. Sounds great. Give her. Wouldn't recommend it at all, but you could. So as we step into this, right, we have a context, and we've got a mocking function, and my preference is always to tell in the context what I'm mocking. And what that allows me to do is, and we'll see this in the output, is it'll tell me what my describe is, and then it'll give me my context, and then it gives me my results. So if I'm going to take and step through a function and mock different parts of it, I get that output in the context. Hey, guess what? These test results were in this context. Makes it pretty easy to read. So to create a mock, use the mock parameter, or the mock function name. You give it a command that you want to mock. Because I'm using a module, I tell it I want to mock that command in that module space. So if I run that same command outside of that space, it doesn't get mocked. And vice versa, if I don't tell it to mock it in that module space, it'll mock it outside of that module, not inside of it. That'll bite you enough times and you'll remember it, I promise. And then I tell it what I want to mock it with. And within that mock with, you can write anything. Doesn't matter, it's just another script block. When that system runs and it calls that function, it's just going to do a blind execution of that script block. So be careful if you're trying to mock a function, say remove item, and within that mock with you put remove item. You will enter a recursive loop and you will crash whatever it is that's running PowerShell. It's glorious.
Spoken like somebody has experience.
A couple of times. And so there's no requirement to put anything in the mock with, right? So in the first one for test path, I mock it with $false. The second one, I mock it with nothing. It's just an empty script block. So when it calls remove dash item, nothing's going to happen. That's really cool, right? I can now run my destructive commands and have zero concern that anything's actually going to get deleted. And I can mock anything. Doesn't matter. And I don't mean that like I'm a comedian and I can mock anything. I mean literally anything within PowerShell is what I can mock. And so as we scroll down past the mocks, we then see, right, I'm looking for that command should throw an error if the path is not found, right? And this now looks familiar, right, where I'm again calling remove temp data, and I'm saying it should throw. Only this time, I'm not actually passing it anything, right? Because I don't need to, because I've mocked these items up top, right? So I know when that function runs, and it runs test path, it's going to return a value of false. And it's now going to take and execute that throw error. Does that make sense? This is usually the point where I lose people, where I start talking about mocking and how I can override, or to use the PowerShell terms, that I can clobber commands within the PowerShell context. Okay, I'm going to assume everybody knows what I'm talking about. So we now move down a little lower to our next context. And this looks really familiar, where I'm calling remove temp data, passed it to result. I take result and I pass it to should, and I say because we're testing things, and then I do a test path to say that that should be true. And at the very end here is where I get actually destructive. And I actually want that command to run and delete things, right? And sometimes that's important to do too in your Pester test, is to actually execute the action and confirm that it does what you thought it was going to. Because as great as the mocking system is in Pester, it's still just another system. It has the ability to fail. Test in as many different ways as you possibly can. Cool so far? All right, so let's run this. And as it ran, everything looks great. Again, I get passes the whole way around the board. And if you remember, right, and I just want to prove to you that mocking works. When I come back to this remove temp data, it defaults to a path that exists. And I have this error condition here that says, hey, if that test path doesn't work, throw an error. And in my Pester results, it confirms to me that it threw an error through using the mock. Right? No? Nobody yet? All right. I'll get there, I promise. So let's look at some really cool advanced mocking. So we're back to a get, and I have two parameters now, a filter and an include. And I say, hey, if I've used filter, I want to get child item. If I didn't, and I've included include, here's what I want to output. And if I haven't done any of that, I get a completely different set of output. And at the end of all of that, I'm writing out the results. Simple, right? Questions on the function before we get into the mocking? Right? There's nothing destructive about this. It's strictly reporting. So we get into the test. And this is where you go, oh my God, that's a really large Pester file. No? Was I the only one that did that? All right. So again, we start off with our same 3 lines. Have I said that enough to like beat that into everybody's head that you should start with those 3 lines? Like that's a really big deal, and I really want to push that as a, put that in your Pester tests. So we then move into a describe. We're getting our name data, and we're testing a filter parameter. Wait a second. I didn't talk about filter parameters. That's weird, right? So we'll figure that out. Then I have this tag thing. And tags are really cool because I can take and scope how I want Pester to run in the test based on tag. So I can take, and when I call invoke -pester, I can say -tag and run just those tests. So if I have that 400-line Pester file that's got, you know, tests for everything I do in my workplace, and I only want to test that one function because that's what I've made changes to, I can pass a tag to it, and it'll only run that one describe. Pretty cool. So now we move into, we have a mock of get child item, and we have this parameter filter of $filter and $path. And that's within the context of get temp data. And I've mocked that with this huge hash table of stuff. That all it does is make the hash table and outputs. Simple. So I move down to the next line and I go, I'm mocking command name get child item. Well, that's weird. I just mocked that. Why would I be mocking it again? And I have a parameter filter of $path and $include in that same module name. Only this time, I'm using this Pester commandlet called new mock object. And new mock object is great. It does so many wonderful things for you. It'll literally generate an object type of whatever you've passed it to. Pre-populate all sorts of information for you. It's fantastic. As you get further into Pester, new mock object will become one of your best friends. It's great. So the difference that we've seen so far is this parameter filter. Right? And if we go back to our function, we can see there's this path and a filter once. And then we look down here and there's a path and an include. And then down here there's just a path. And that kind of mimics what we've done in our mock commands, right? We've got a filter and a path. We've got a path and an include. And the point that I'm trying to get to here is using that mock system, I can even scope what type of a command call I want to mock. So if I don't want to mock remove item with -what if, I can exclude that in my mock and only execute my mock when it's going to actually be destructive. Yeah? All right. So then we move down into our it statements. And we expect that it's going to return a directory object. And our test is to run get temp data, right? And this is what we've seen before. Only this time, we're actually checking to see that what we got in our result is greater than 2. Hey, that's nice, right? That we can actually say, hey, it should be at least 2 or more in native Pester language, which means that the output that comes out is going to be natively easy to read. Again, right, that's kind of the whole selling point is we can do this really cool testing and still make it easy to human read for people that are not PowerShell experts. That's fantastic. So then we move into, now wait a second, that's not in an it statement. Why wouldn't we put that in an it statement? Right, because so far everything has been either within a mock call or within an it statement. Why would I have put, maybe this is a typo, right, because I'm new at presenting, so maybe this is a typo. Not at all. It's outside of that it so that I can assert that that mock was actually called. And isn't that a cool test? That I can actually within Pester say, hey, guess what? I defined this mock up there, and I'm going to run that command, and then I want you to actually tell me that you ran that thing I told you to. It's like a recursive testing within the framework. That's awesome. And it's very simple, because I can even take and I can specify that I've mocked it within a specific module, just like how I set up the mock. And we see that again down here too, that I can even take and assert that I've called the mock for that specific parameter filter. So if I mistype something, right? We all do that all the time, right? We're trying to write something cool out, and well, we've made it to 400 lines and we forgot that thing up at line 100 was not what I expected down at line 400. This gives me the ability to make sure that I'm mocking things correctly the whole way through. Everybody still with me? Okay. Again, this is where I usually lose people and I start getting the funny looks or people just start leaving. So so we move down here, and the rest of this is pretty straightforward testing that we've already seen. So let's run this. Do we feel like this is going to work?
Everything else has, so sure.
All right. And sure enough, it does. Everything's green across the board. And we have, to that point, we have that really nice, hey, we're asserting that we're mocking, and we get all the parameters listed. Right? I think this is really clean output. It makes it really human readable as to what's going on within Pester. Cool? So I'd mentioned before that I use Pester a lot for the modules that we build and we use at where I work. And so it's, well, where do I put those tests? Do I ship those as part of my module? Is that important for other people to have those tests? Or do I have to change things around and now I'm into some sort of complicated space? True answer is there's 2 places that you should put Pester tests in your modules. One, for your unit testing, which is what we've covered so far, should not be shipped with your module. There's no purpose to it. There's no benefit to anybody. Don't do it. If you're using some sort of source control, make sure it's part of that project and it's checked in and you version your tests, but don't ship it with your module. Within your module, though, you should be shipping Pester tests. And those Pester tests should be for infrastructure testing. And that's where we get into, I'm now testing a deployment, I'm testing my Exchange environment, I'm testing that the internet exists. Whatever that is, right? I'm moving outside of PowerShell, and I'm now looking at the broad landscape, right? These are things that I support. This is what I want to get in on. So I will reference that the module structure that I'm I'm presenting is driven largely from a Microsoft project called Operation Validation. And the context there is, do you guys know who Rambling Cookie Monster is? Does that name ring a bell with anybody? Right? His real name's Warren Frame. He's a great guy, if you've never met him. Him and I believe it was Brandon Olin started the project and went, hey, we want to ship our infrastructure test with modules. We should have a system for that, right? And we should call the folder in our module diagnostics. That makes sense. Then we should have subfolders in there called simple and comprehensive. Will the thought pattern be, if I run a simple test, I get a high-level result. Are things configured correctly? Are they not? And now, keep in mind, that's not, I'm monitoring with Pester. I'm testing with Pester, right? Configuration is very different from up-down, right? Because something can be up and wildly misconfigured. I'm sure nobody's ever found that in their job, that something was online and didn't it all work. So that's really what we're after, right? We have simple tests that tell us high level, is something roughly configured correctly or not? And when we get a failure in that simple test, we can move to our comprehensive tests and find specifically where that error is. And this is where we get into the mindset of Pester. And how do you take and develop things that are in that structure? I personally struggle with that every day of what's a simple test, what's a comprehensive. So don't get hung up on it. Just know that that's existing nomenclature that is pushed. I believe in that. I'm terrible at executing. So we look here on the left, and we see that we have a module folder. And inside of that, we have this diagnostics folder. And inside of that, we have a services.test. We have a function called remove temp data. And then we have a test, remove temp data.test. That's all really cool. The intent here is our build system would take, and when I push a change to my master branch, anything in that test folder, it would run Pester against. And that would carry out all of my unit testing for everything that's in my module and make sure that things are correct in the code that I'm about to publish, right? After that all pass, I would publish what's in my module out to ideally your NuGet repository that you have at work, right? Everybody's got a NuGet server. Cool. And then I would take and be able to distribute that module to my coworkers as appropriate, and we'd have a set of commands that we could all run together. When something broke, as it always does, we have a central place to start our troubleshooting. We can all say, hey, run Pester against your diagnostics folder and find out where the error is. And the amount of time that it'll take for Pester to execute versus you to log into an RDP, 9 times out of 10, Pester will return first before you are all the way logged into that server. And I say that from experience. Questions? Anybody? Not yet? Yeah.
So I apologize, I'm a little new to this side of the house. I've done unit testing on the .NET side. So my question when you brought up infrastructure testing, so where's the line where you're testing the module versus actually testing infrastructure? I'm assuming that you're writing tests to make sure that infrastructure tests work. Those tests get executed by, as you said, as you deploy those out. So kind of like, how do you structure those so that you kind of tell the difference between what's a module test versus what's an actual module to deploy that executes it?
Yep. So the methodology we run at Plexus is each module corresponds to an application. So we have an Exchange module, we have an Active Directory module, we have a VMware module that are all commandlets that we've written internally to streamline things that we do.
Okay.
So for example, if we have a new Plexus VM commandlet, I would have a unit test that would be in this test folder that would say new dash plexus vm.test.ps1. And then, separate from that, in my diagnostics folder, I would have a cluster.test.ps1. And the distinction between those is the cluster.test connects only to VMware to test all of my clusters that I have configured in that vCenter. Whereas my new Plexus VM.test is going to import my function for making a new VM, do my mocking, do my testing, and make sure that as I change how that functions, everything is still configured as I would expect it to be.
Okay.
Does that make sense?
Absolutely.
It's really
How
a
do you do change management then over time of infrastructure, I guess is because I'm thinking like this would be very applicable to a lot of organizations in this area, but they don't have anything. So it's always some dude went out and set up Exchange.
Yep.
So I'm assuming the first step would be information gathering on what the configuration is and then writing a test to make sure that they are passed. But when you guys do updates to these environments,
Yep.
do you go from the change side of things first, or do you go through the mocking and then the testing and then pushing it out through this infrastructure?
What we default to, and this is going to sound funny, is JSON files.
Okay.
Quite literally, it's a, we strive to write tests in such a way that it doesn't matter whether it's Exchange 2010 or 2013, right? We have in our JSON file a distinction between those two.
Okay.
And so as we roll from one thing to the next, all we do is we pass a new JSON file to that test.
Okay.
And so when we start a deployment, we run the test, make sure everything's green.
Mm-hmm.
We start the deployment, we run it again, we make sure everything's red, right? Because if we've started the deployment and some things come back green, that's probably a really big issue and we should probably get on that,
And
right?
does this support any kind of rollback or transactional methodology, or is that something you have to write?
So that's where I would say you should start looking at DSC
Okay.
and use DSC to integrate into your Pester tests. And if we're curious about what I mean by that, I'm happy to get into that at the end of this. Just usually when you start talking DSC, that's another whole long-winded conversation. But yeah, no,
I'm assuming that you had counted for that because I can't imagine halfway through an Exchange rollout that fails that you don't have a mitigation plan.
well, and so let's be clear that Pester is not actually doing the deployment. Pester is a system that sits really like a witness to what your deployment's doing, right? And if Pester is the one invoking changes in your environment, I'm not saying that's wrong because people do that, but I would not recommend it.
So an example would be Microsoft recommends deploying Microsoft SharePoint leveraging PowerShell. So
Yep.
I would create a script that would do the actual deployment, then I would create a Pester test
Yep.
that would test the net results of that deployment.
Yep.
And then
So to think that the whole way through, right? So you have this script that deploys SharePoint. Unit test that with Pester, right? And have it run that script mocked as appropriate to go, yep, no, I have a lot of confidence now that that script will actually deploy SharePoint. Then when it's done, then you can run your infrastructure test and go, yeah, no, it actually deployed the way I expected it to. And you should be able to use the same JSON file kind of the whole way through.
Okay, and is the JSON file setup something that you guys put together yourself, or is that packaged into this?
JSON file is all stuff we've written by hand
Okay.
very laboriously.
No, but I mean, is the framework for this Pester setup to accept those? Did
No,
you create your own, or did you write a?
we wrote our own.
Okay, no, that makes sense. Sorry, I'm not trying to
Nope,
derail you,
nope,
make it
nope.
just-
And I will skip ahead a little bit just because we're talking about that. So some things that I'm going to plug are some of my own projects, right? Because I'm up here, you guys are forced to listen to me. Here we go. So I have two things on GitHub that I pseudo maintain. The first one is a project that I call Red Pen, and its entire point is to make, right, so you've put these tests into a module, you can install that module anywhere on your system, right? So how do you give set instructions to any of your admins how to find those tests and how to run them, right? That's kind of a problem. The operation validation framework, OVF, from our friends at Microsoft was meant to solve that. I didn't get a whole lot of value out of it, so I kind of rolled my own and call it Red Pen. It enables me to email results and ingest JSON files so that I can take and know that I have valid JSON data before I go out to test. And I actually use Pester to test my JSON file before I use it to test my environment. I'm telling you, there's so many use cases for Pester, it'll change your world. It's great. The other one is Pester exams. And the intent of that is to start standardizing some of the infrastructure tests, right? Testing Exchange doesn't really matter where Exchange is installed. It's all Exchange. You can test it all the same. The only thing that should change is your JSON file, right? So if I go from where I work to UW-Madison, it's still the same Exchange. I should still be able to send a configured JSON file into those same set of tests. So that's kind of what I'm striving for with the exams, is to kind of build that. Guess what? I don't have to reinvent the wheel. You just grab this thing, put it in a module, and away we go. The last one is kind of so you want to get started with Pester, and you don't really have anything at your job today that would fit into this, or you don't think it would fit in today. This guy named Joel started a PS Cones. I believe that's how you pronounce that. And it uses Pester to show you how to write Pester. Yeah, no, I promise it's great. When you run it, it'll take and it creates a directory of Pester tests that when you take and you do a test against that directory, it tells you all of the things that are wrong. And so you go browse through the directory, you find the tests, and you have to make corrections to the tests to get it all to pass. And so it's one of those, yeah, no, this is fantastic. So it's a great way to kind of, I don't have anything today that I could use it with, but I really want to learn it. It's a great way to cut your teeth and really get into the kind of nitty-gritties of not only Pester, but PowerShell as well, right? Because you have to know PowerShell to fix the test. So that's my sales pitch. Does that kind of answer all of it? And I promise, if you want to talk to ESC later, 100% in. So we're talking directory structure with modules. Is that good with everybody? Yeah? Cool. So the only thing I wanted to point out there was, now that I've moved my test from being in the same directory as my function, those first 3 lines that I kept repeating, I got to change that a little. Right? Because now I got to traverse the directory structure to where my functions are. It's the same 3 lines, just a little different. Right? And so if we look at that, I get a slightly different 3 lines. And the only difference here is I'm swapping out tests from my parent directory, and I'm putting in module/functions. Not that big of a change. It's still the same 3 lines, just a little different. Does this make sense? Do you guys publish modules? Or is modules not really a thing? Yeah, kind of ish. Okay.
There's been code put up, I'm storing this stuff. There's been things put up on the internet. I look at it, I go, wow, it's me.
Are you saying you look at the internet?
Sometimes even at work.
Looks like someone put a lot of time into this.
I'm at the point where I can appreciate, like, I'm getting a lot of this because it's really cool,
Mm-hmm.
but it's kind of, like, I'm hoping to get to this at some point. But right now, it's just soaking it in, and, like, this is a valuable tool. How can I learn to utilize this? Is what I'm taking away from this evening.
My sales pitch there is start making a module, even if you're the only one that uses it. Write Pester tests for your stuff, and use Saki to build it. And that'll take you really far in a lot of different things. If you have questions, I don't know where I post my contact information, but I'm on Twitter, Reddit. I do email, sort of. So.
Paul, post that on the meetup thing.
Okay. How's our going?
So far, this is all great for when we have like singular things to test, right? And yes, we can do multiple assertions in an it block, and that allows us to test multiple things. But I can get really wordy really quick, right? Think about an infrastructure test where you want to know, say, if a service is configured as automatic, that it's running. How many times would I have to write that it statement for every service on a server? You could, and that's valid. Completely valid. Or I could use test cases, right? Kind of streamline some of that writing that I have to do. And what that looks like is this services.ps1. I can say, hey, look, I have super important services that I want to run, right? These are the only things that I care about on whatever system I'm going to run this on, right? So I can make a hash table, and it's an array, and I give it values, right? I expect these things to be stopped, or running, or manual, or automatic, or whatever, right? And I can then take that array, and I can pass it in to my it statement. And now I have a really generic services test. That again, if I was using a JSON file, right, all I have to do is update that part of the JSON file with, I expect these services to be in this state. And now, when we go back to our deployment mechanism, right, I have a pre-deployment JSON. I have a during deployment JSON, where I can then say, hey, run this, and everything better come back green. Because then I know we're ready for the deployment. That means everything's stopped, shut down, whatever. Whatever I wanted it to be, it's all there. I can now do my deployment. And as soon as the deployment's done, I can take that first JSON, pass it back in here, and again, get all green results. And so now if I'm able to more dynamically test my environment and confirm that things are configured the way I want to. There's some other cool magic going on in here where I have this param statement. If you know anything about script blocks, right, anything that's just a curly bracket, anything that's in that is called a script block. And a script block is just an anonymous function. And a function is a named script block. That's all there is to it, right? So because in a function I can call a parameter and set parameters and do all that kind of stuff, because in Pester this is a script block, I can do that again. And I can set those parameters to be whatever I want, however I want them to be. And that also allows me to take and then pass those into my name. So that as I change around my configuration data and I pass that into it, the name of my test keeps up with the data that I'm passing into it. I have much less to maintain in my test by using this configuration data and by utilizing test cases. Could you also do this with a for each? Yes. Is it as clean? I would argue no.
Well, probably not. But that's where I'm at.
No, right? Like it's, and we're all here to learn, right? So let's run this and see what it looks like. And so, oh. So in my configuration data, I said that I expect this web client to be stopped in manual, and I get that feedback that my service is stopped, right? And then I expect WinRM to be running, and I again get that feedback that it is in fact running. That's pretty cool. Questions? Cool, right? Test cases are really cool. It's a awesome part of PowerShell. So an example that I had skipped over, unbeknowingly, if I do invoke Pester, to your point of the for each loop, this is the kind of data that I get out of it. Is I say, hey, I'm looking for anything with a startup type of automatic. I do that for each loop, and then I can check the status. Right? So to your point, you can do it both ways. Could I do more to make this more descriptive? Yes. Is it important from my standpoint to try and fix that up? No, I'd much rather have that config data and be able to test both that something is running and not running. In my opinion, that's what's really important, is that it's not only what's running, but what's not running that I need to test for on any application, anywhere that I go. That's really important, because that's all part of configuration, right? And that's kind of draws the line of where you talk about monitoring. Monitoring will just tell you if it's up or down. It doesn't tell you if it's supposed to be up or down. That's kind of that line. My last example, and we've kind of already covered this, was tagging, where you come in and I have my super important services. And I did not actually put a tag on this. Wow. Where did I put it? Oh, so I put it in here. So and here's where I can put in, right? I can put in as many tags as I want to into that describe. And that's where we come back to that, the simple directory and the comprehensive directory, right? Anything that's in that simple directory should have a tag of simple. And anything in the comprehensive should have a tag of comprehensive. And that allows you to quickly target those different things. And then you can add in the extra tag of the test name that you're expecting from your simple test to fail. So when I get a simple test failure, I can pass in comprehensive and the name of that test to my comprehensive tests and get just that comprehensive troubleshooting for that test, whatever that is. Cool? Questions? Comments? Because that's kind of the end of my presentation. I have other things that I can show, but I really want to, this is the core stuff, this is the important stuff, this is what I want to make sure you at least have a handle on, that you can start doing more research. You start digging into this and you kind of have an idea when you look at those examples out on GitHub, right, where they show here you do a match. Well, you know that the match needs to go inside an it, and an it needs to go inside a describe, right? That's really how you get started and you become really good at this. Yeah, man.
Other than the module slash function, is there a structure recommendation? You may have covered this.
No.
But, how to actually create your PowerShell so that it's easier to test. I know when we were doing unit testing, you wanted to eliminate UI layer and data layer, and you wanted the business layers, where you wanted to structure your functions in such a way that they were testable. Are there any strategies for creating testable methods, functions?
The premise, the PowerShell best practices of have one function that does one thing and keep it finely tuned to that one thing, it will carry you very far in Pester world. A further point to that is keep one function per file. So when you go to import module on that file, you're only getting the function that you're trying to unit test, right? It's okay to import all that other stuff. It just slows down your testing time. Whereas if you're doing one function at a time, everything just runs faster. You eliminate the load. To that point, right, some people will say, well, a module will load faster if you have all your functions in the same file. And they're 100% correct. And that's where, if you start using Saki, you can take and have as part of your build It combines all of those functions into a file.
So
Obviously,
you're a monolithic module guy.
when I publish it, yes. When I'm source controlling it, it should be individual files. Because those two are distinct purposes. One's for human readable, the other one's for functionality. When I've published a module, I don't expect anybody to be reading through it.
That was more me being a smart ass.
So, obvious downsides to this so far are I have to be at a PowerShell window, and I have to know how to run Pester, and I have to be watching for the output. Right? Come on, we're IT guys. We don't like to do things. We like to just have things work for us, right? And having to actually be at the keyboard to do these things is not helpful. Right? Wouldn't it be great if it could just run and tell me what the results were?
Isn't it like automation?
Yes, just like automation, right? Right? That's fantastic. So my red pen project will actually email you the results of the Pester tests. So you can dump it into a task scheduler. It'll run all of your stuff. You'll get it in an email, and then, right? So I get a report from a number of different systems overnight. So when I wake up, the first thing I can do is look at my phone and scroll through and see, hey, is everything still the way I expect it to be? That way then, when inevitably the service desk calls me an hour later, I can tell them it's not mine. They got to call somebody else, right? So that's cool. It's also really cool to be able to take, and do you guys have like separation of duty, right? Where not everybody can log into your servers, right? Right, that's I know that's not a thing at some places, but right? But it'd be cool to be able to take this Pester data, right, and have it published to like a website, right? Like where you could maybe like browse to that server URL and get like, hey, what were the results of all of my Pester data? Wouldn't that be cool? Right? So, and I will admit that it's not quite done yet, but universal dashboard, anybody? Anybody? Yeah, right? Like it's, so they just released 2.0, and there's a community version of it, and universal dashboard, if you're not using it, it's fantastic. It's a little cumbersome to get into, but once you're in it, man, you'll wonder how you ever did anything before. So, I wrote a function that will, well, I'm in the process of writing a function, to take my Pester data, right? So I do an invoke Pester, and I pass that Pester data to this dashboard creation. And the beauty of that is, when I run this, da-da-da-da-da-da. Oh, come on, you're not even gonna let me like, I'm not even connected to a network. Oh, you're killing me.
Obligatory Linux is better comment.
Oh, it's no. All right, so that's interesting.
Well, thank you, Windows.
Well, it's okay, so that shoots all of that just square in the ass. All right, so the only other thing I have to talk about is, so we talk about unit testing, and we want to make sure that if we change something in that function, our tests tell us that things still work, right? Well, there's the concept of code coverage to say, hey, did I catch everything, right? That's kind of important. Like, did I forget to test some part of that function? Did I miss something? And Pester has a code coverage test to it. And so this I pulled directly from the GitHub page, right? It's a very simple function 1, function 2. There's nothing real special about the functions, just very straightforward stuff, right? If I look at this coverage test.tests, right, I have my same 3 functions there again, or same 3 lines, sorry. And then when I go into testing all of this, same as always, right? The difference being, when we actually go to run it, we can call it with this code dash coverage. And that's going to change our output from our Pester test. Oh. Yeah. Now let's run that. And so now we get this nice report of our code coverage as well, right? We get our usual Pester data out, but then it also gives us this coverage report. It tells us, hey, guess what? Out of what we've written in Pester, we've only covered 60% of what we have in that file. Chasing the 100% of code coverage, or especially for any function that is of worth, can be very time consuming. Right? It's one of those, and then inevitably you'll make some changes to it, and you'll lose all sorts of coverage. There are people that believe 100% code coverage is absolutely mandatory. I'm not one of those people, right? I don't know about you guys, but I'm not paid for my code coverage. I'm paid for the work that I output. So I personally count anything over 50% as sufficient. It's probably not like correct, but again, that's not my job. I'm trying to automate things and make things fast and provide some like base level protection against me, right? As long as I have that base level protection, I'm good. Works for me. Make sense? Questions, comments? That's what I got. If we want to talk DSC, I can talk DSC or whatever.
DSC got a whole other conversation.
Right, yeah, that's
All right, thank you very much.
cool.